All right, so far in your understanding of atoms in Unit 2 is that there are three subatomic particles that make up an atom: electrons, neutrons, protons. Neutrons and protons, as you learned from 2.1, make up the density of an element. That's the mass of it. And we're going to get into how they interact now in 2.2. So I gave you a brief overview of where they are located in an atom, but also now we got to know what the math behind it is. So you can actually figure out how many protons there are if I give you an element, or how many electrons and neutrons. So they interact differently based on, or they don't interact differently, but they interact with each other so that the protons and neutrons and electrons all have some sort of relationship. And that's what I have right here. The relationship means that if if someone gives you the math problem here, I have to give you two of the three variables. So if I say 3 plus 4 equals what, you can solve it. But if I go 3 plus what equals what, these numbers can be a ton of different answers. So the whole point is I have to give you enough information to answer the question. So for atomic mass, for example, if I give you a question with atomic mass, you have to know that, somehow I have to give you the number of protons, okay, and I have to give you the number of neutrons, because the protons and neutrons equals the atomic mass. So either I give you the atomic mass and the protons, I give you the atomic mass and the neutrons, or I give you the protons and neutrons somehow. All right? So it can be tricky though, and we'll get into that, but for example, I can give you the number of protons by telling you what element it is, because every element has a different number of protons, and it's very unique. So if I say the number 10 protons, if you go to the periodic table, is neon. So neon is the only element with 10 protons. So that's very important. So there's different ways of telling you this stuff. Another example, I can tell you the same number of I can ask you what the atomic mass is by not even giving you protons. I can say there are 5 neutrons and 6 electrons. And I say it's a neutral atom. So if I say neutral, that means the electrons equal the protons. So 6 electrons means 6 protons. And if you go to the periodic table again, that's carbon. So carbon has 6 protons, and that makes it, that allows you to get the number. So I'm just trying to give you an idea that it's not so simple where I just say protons and neutrons or give you the atomic mass, okay? Same thing, charge. So this is the number of protons minus the number of electrons. So if you get a 0, that means it's neutral, okay? That means the protons and electrons equal the same number. So this number can change, okay? This number can change in an element. But this number cannot, unless you're changing the actual element. So keep that in mind, all right? So they all interact, basically. So I'm just trying to get you an idea of how they interact, and even the element. So I'm not going to write a bunch of stuff on this. I think examples will be helpful. But the idea is they all interact somehow, all right? So let's go through some examples here, all right? So let's do this. I'm going to use one of your homework sheets as an example, but let's just I'm going to change it up a little bit. So I'm going to say that BR, and it says 82. I can write that as BR 82 here, okay? So I want to know I want to know the atomic number, so here's the list. So I want to know the atomic number, I want to know the mass number, I want to know the number of protons, the number of neutrons, and the number of electrons. Okay? The rest of the stuff don't worry too much about. So these are the things that you need to know. All right? So looking at this, the first thing you want to look at is notice that there is nothing here. There is nothing here. That would indicate the charge. All right? So you assume the charge is 0. That means protons equal electrons. So you know bromine, if I go to bromine, I'm just looking over there right now, it's got 35 protons, I think. I gotta look a little carefully. Alright, so it has 35 protons. I guess I'll just grab a periodic table. Alright, so bromine has 35 protons. Alright, so the atomic number, or back to the charge, protons equal electrons. So I know that the number of protons is 35 and the number of electrons is 35. Because they equal each other, because the charge is 0. There's nothing there. It's basically 0. You don't write 0 though. Okay? The atomic number is the number of protons. So that equals 35. Alright? The mass number is protons plus neutrons. And it gives that to you right here. That is the mass number. This is protons plus neutrons. So I just throw that in there. So that equals 82. Okay? And now the number of neutrons. Well, you know protons and neutrons equals 82, so simply go...
Hey, at this time, our fall athlete amp camp is going to start in the library. All athletes that were invited by your coaches to attend the fall athletes amp camp, please head to the library. We're going to start up.
Perfect timing on that one, but anyways, I'm too far into this video to stop. I'm just going to keep going. So anyways, 82 is the number, or is the mass number, and it's the number of protons and neutrons. So if I subtract the number of protons, I get the number of neutrons. Okay? So I'm going to erase this because I know protons. The number of protons is 35. So now I just have to do some subtraction. So 82 minus 35, 45, 55, 65, 75. We got 47. 47 neutrons. Glad I know how to do math. All right. So 47 neutrons is that number because 47 plus 35 is 82. Okay. So I think that's a basic idea of it, but I want to give you a couple different options here. Let me give you a different one now. So I'm going to keep all of this because that's kind of what I'm asking for. All right. All right. So now I'm going to, let's do a different one. Let's go. I'm going to give you something different this time. I'm going to give you the charge. So the charge we could actually put down here. Let's say the charge is -2. And I'm going to give a different one than the periodic table tells you. I'm going to say the mass is, the mass number is, so let's see what they're giving you. So 32, the mass number, okay. We'll go, the mass number is 16. And the number of neutrons is 8. So you got to figure out everything else, okay? So that means you got to actually know the element too. All right. So first of all, mass number is 16. That doesn't. I mean, there's a lot of elements that could weigh 16. The average of them is always a decimal, but because there's a variety of weights. So you can't just assume that weight means an element, okay? So that's not going to help, but the number of protons always does. So is there a way to figure out the number of protons if you have the mass number and neutrons? And that's definitely true, because the mass number equals 16 because it's the protons plus the neutrons. So you have 8 being the neutrons, so basically 8 plus what equals 16. So the number of protons is 8. So you're good with that. You know the charge is -2, and you know that that would be number of protons minus the number of electrons is going to equal -2. Well, you have the protons, so it's 8 protons. Number of electrons you don't know, but it's -2. So 8 minus what equals -2? That would be 10. So the answer is
Fall
10.
athlete app camp, starting up in the library. Fall athlete app camp.
All right, so the answer is 10 electrons. All right. So now we have all these numbers now, atomic number again, number of protons. These are like the same thing, by the way. Okay. Now we have to figure out the element. The element, the atomic, there's only one element with 8 protons, and that's oxygen. So you write oxygen, but it's an isotopic formation because that basically means it's one element. It's not the average of all the weights that's on the periodic table, just one of them. And if you need to know why there's an average of weights, you haven't looked at that tutorial, please look at it. But basically, this one is 16. And if you want, and then you would put a -2 there to indicate that it's got a -2 charge. All right. So that's just another example of how I can ask you different questions on this and kind of go through this more than one way. We could do one more. since we're kind of on a roll here, why don't we do one more? All right. So I'm going to give you a different one. I'm going to try to make a variety here. I'm going to go, let's go Li plus, and it's a 7, okay? And the rest you got to figure out on your own, right? So it's very similar to the first one, except now it has a charge. So I know lithium weighs 7, that's its mass number, so I'm going to put that there. It's number 3 on the periodic table, so the atomic number is 3, and that means the number of protons is 3. The rest of this mass is neutrons, so 3 plus 1 equals 7. That would be 4, okay? 4 plus 3 equals the mass number, neutrons and protons. Electrons would be, remember, it's protons minus electrons. I have a positive 1. Imagine that's just a 1 since it just has a positive. So I know that has 1 less electron than it has protons, because these are positively charged. So I have 2 electrons, and the charge is plus 1. Right? So these are examples of questions I can ask you. Knowing the relationship of how neutrons, protons work, and understanding how to write an element and the symbol and writing the mass number, you'll figure this out pretty quick. But it just takes a lot of practice. So keep practicing. Let me know if you have any questions, but there's plenty of worksheets with answer keys, okay? Good luck.